The year is 2025. In a classified facility deep within America's heartland, something extraordinary is happening. A fighter jet, unlike any the world has ever seen, sits on a reinforced runway, its sleek contours revealing almost nothing about the revolutionary technology housed within. What you're about to discover about this aircraft will forever change how you understand American air superiority. While the rest of the world races to perfect their sixth-generation fighters, America has quietly leapfrogged ahead, developing what military insiders are calling the seventh generation of aerial combat technology, a quantum leap beyond anything currently in development. This isn't science fiction. This is American ingenuity at its finest, the culmination of decades of research, billions in investment, and the unmatched dedication of our military and aerospace pioneers. By the end of this video, you'll understand why foreign powers are scrambling to catch up to what may be the most significant advancement in military aviation since the invention of the jet engine itself. The question isn't whether America's seventh-generation AI fighter jet is ready for combat. The question is whether the rest of the world is ready for it. If you're proud of American innovation and military excellence, type EAGLE in the comments to show your support. To truly appreciate what makes this seventh-generation fighter so revolutionary, we need to understand the evolutionary path that brought us here. The story begins with first-generation jet fighters like the F-86 Sabre that fought in the skies over Korea. Simple by today's standards, these aircraft represented the transition from propeller-driven planes to the jet age. Second-generation fighters, including the F-104 Starfighter, introduced supersonic capabilities and basic radar systems. By the time third-generation fighters like the F-4 Phantom arrived during the Vietnam era, we saw aircraft that could serve multiple roles, fighters that could also act as bombers and reconnaissance platforms. The fourth generation brought us iconic aircraft like the F-16 Fighting Falcon and F-15 Eagle, planes that introduced fly-by-wire technology and unprecedented maneuverability. But here's where things get interesting. Fifth-generation fighters, represented by the F-22 Raptor and F-35 Lightning II, marked a dramatic leap forward. Stealth technology, advanced sensors, and network-centric warfare capabilities transformed these aircraft into information platforms as much as weapons. And the sixth generation? Just this past March, President Trump announced Boeing's F-47, America's first sixth-generation fighter, designed to incorporate artificial intelligence, even more advanced stealth, and the ability to coordinate with unmanned drone aircraft. But while the media focuses on the F-47, something even more advanced has been developing behind closed doors, something that changes everything. Why is the seventh generation such a monumental leap forward? Stay with me, because what I'm about to reveal next explains why military experts are calling this the biggest transformation in aerial warfare in our lifetime. For years, rumors have circulated within defense circles about a classified program operating with a black budget, developing technologies well beyond what was publicly acknowledged. These weren't just incremental improvements, but revolutionary approaches to flight, combat, and battlefield awareness. What makes this program different from previous generations isn't just improved versions of existing technologies, it's an entirely new paradigm of what a fighter jet can be. The seventh generation fighter represents the convergence of several cutting-edge technologies. First, artificial intelligence that goes beyond being a co-pilot to becoming a true combat partner. Unlike the AI systems in development for sixth-generation fighters, the seventh-generation AI can process battlefield information, make tactical decisions, and learn in real time, all while maintaining a neural link with its human pilot. Second, revolutionary propulsion systems that allow for hypersonic speeds exceeding Mach 5, nearly twice as fast as the fastest fifth-generation fighters. At these speeds, an aircraft could cover 1,000 miles in just minutes, dramatically reducing response time for critical missions. Third, adaptive stealth technology that doesn't just evade radar, but actively manipulates electromagnetic signatures, making the aircraft nearly impossible to track using any current detection methods. Fourth, and perhaps most groundbreaking, is the potential for atmospheric exit capability, allowing these aircraft to briefly operate at the edge of space, completely changing the strategic dynamics of aerial combat. While the Pentagon officially maintains that sixth-generation fighters are the focus of current development, the technological foundations for these seventh-generation capabilities have been systematically developed over the past decade through various unrelated research programs. The pieces of this technological puzzle have been hiding in plain sight, only now coming together to form a picture that is as clear as it is revolutionary. But how did we get here so quickly? The answer is both surprising and inspiring for anyone who believes in American ingenuity. The heart of what makes the seventh-generation fighter so revolutionary is its artificial intelligence system, a quantum leap beyond anything currently deployed. Traditional fighter jets require pilots to process enormous amounts of information while operating in high-stress environments. Even with advanced heads-up displays and sensor fusion in fifth-generation fighters, human cognitive limitations remain a bottleneck. Sixth-generation fighters are beginning to address this with AI assistants. Think of them as advanced co-pilots. But the seventh generation takes this to an entirely different level. Its AI system doesn't just assist the pilot, it functions as an integrated extension of human consciousness during flight operations. Using neural interface technology developed through DARPA's next-generation non-surgical neurotechnology N3 program, pilots can interface directly with the aircraft's AI, creating a symbiotic relationship between human intuition and machine processing power. This allows for number 1. Instantaneous situational awareness across vast battle spaces. Number 2. Predictive threat analysis that anticipates enemy actions before they occur. Number 3. Autonomous operation of multiple unmanned combat aerial vehicles as extensions of the main aircraft. Number 4. Real-time adaptation to changing battlefield conditions. What makes this truly remarkable is how the AI learns and evolves. Unlike conventional systems that require extensive programming and updates, this quantum neural network adapts through experience, becoming more effective with each mission flown. It combines the best aspects of human creativity and machine precision. One senior Air Force official, speaking on condition of anonymity, described it as having the combined experience of our best fighter pilots instantly available in every cockpit. The results from early testing have been nothing short of extraordinary. In simulated combat scenarios against our most advanced current fighters, the AI-human partnership demonstrated a success rate that would fundamentally alter the balance of power in any future conflict. This technology isn't just an incremental improvement, it's a paradigm shift that redefines what's possible in aerial combat, and it's exclusively American. While AI forms the brain of the seventh-generation fighter, its revolutionary propulsion system is its beating heart. Traditional jet engines have fundamental limitations in terms of speed and altitude. Even the most advanced fighters today struggle to maintain speeds beyond Mach 2 to 3 for any significant period. The seventh-generation fighter shatters these limitations with a hybrid propulsion system, combining elements of scramjet technology developed through the X-43 and X-51 programs with new pulse detonation engines that generate unprecedented thrust-to-weight ratios. This propulsion revolution enables sustained hypersonic flight, speeds exceeding Mach 5, 3,800 plus miles per hour. At these velocities, the aircraft could fly from New York to Los Angeles in under 30 minutes. More importantly, it can traverse entire theaters of operation in time frames that render conventional defense systems obsolete. The strategic implications are profound. A hypersonic fighter can respond to threats anywhere in the world in minimal time, outrun any existing missile defense system, strike with complete surprise, arriving before defensive measures can be deployed, quickly reposition to address multiple threats across vast distances. Perhaps most remarkably, these engines are designed with adaptive cycle technology that optimizes fuel consumption based on mission requirements, extending range while maintaining stealth characteristics. Unlike previous generations that sacrificed range for speed, the seventh-generation fighter achieves both. The materials science behind this achievement is equally impressive. New carbon-ceramic composites developed specifically for this program can withstand the extreme temperatures generated by hypersonic flight, solving one of the most persistent challenges in high-speed aviation. For America's adversaries, the implications are clear. There is nowhere to hide and no time to respond when facing this technology. For American security, it means an unprecedented ability to project power and protect our interests globally. But speed alone isn't enough in modern warfare. The true game changer comes when combining this speed with another revolutionary capability: multi-spectrum stealth. Stealth technology has been the cornerstone of America's air superiority since the introduction of the F-117 Nighthawk in the 1980s. Fifth-generation fighters like the F-22 and F-35 refined these capabilities, making them extraordinarily difficult to detect on radar. But today's battlefield has evolved. Modern integrated air defense systems now employ multiple detection methods: advanced radars, infrared tracking, electromagnetic emissions monitoring, and more. Traditional stealth has limitations against this multifaceted approach. The seventh-generation fighter introduces what defense officials are calling active adaptive stealth, a revolutionary approach that doesn't just passively reduce signatures, but actively manipulates them across all detection spectrums. This system includes metamaterial skins that can change their electromagnetic properties in real time, adapting to counter-specific detection methods, quantum stealth technology that bends light around portions of the aircraft, making it partially invisible to optical tracking, thermal masking systems that virtually eliminate infrared signatures by redistributing heat throughout specialized dissipation networks, active electronic countermeasures that can project false signatures, creating ghost targets to confuse enemy sensors. One remarkable capability is the aircraft's ability to mimic the signatures of less sophisticated platforms, allowing it to hide in plain sight by appearing to be something far less threatening until the moment of engagement. This multi-layered approach to signature management makes the seventh-generation fighter effectively invisible to current detection technologies. As one defense analyst put it, it's not just that you can't see it coming. You don't even know it's there until it's too late. Combined with its hypersonic speed, this means the aircraft can penetrate the most heavily defended airspace with virtual impunity, a capability that fundamentally changes strategic calculations for potential adversaries. But perhaps the most revolutionary aspect of the seventh-generation fighter is its ability to extend beyond the traditional boundaries of atmospheric flight. For decades, military planners have recognized the strategic advantages of operating in space, but the practical challenges of creating aircraft that can function effectively both within and beyond Earth's atmosphere have been insurmountable until now. The seventh-generation fighter incorporates what engineers are calling atmospheric exit capability, the ability to briefly operate at the edge of space, at altitudes exceeding 100,000 feet, far above the operational ceiling of conventional fighters. This isn't merely about flying higher. It's about fundamentally changing the geometry of aerial combat by adding a vertical dimension that no potential adversary can currently access. At these altitudes, the aircraft can conduct surveillance over vast areas with unprecedented clarity, launch specialized weapons that exploit the unique physics of near-space environments, avoid conventional air defense systems entirely by simply operating above them, rapidly reposition by briefly exiting the atmosphere before re-entering at a different location. The engineering challenges solved to achieve this capability are staggering. Special life support systems, radiation protection, and propulsion that functions in the near vacuum of high altitude required entirely new approaches to aircraft design. What makes this particularly significant is how it integrates with America's space capabilities. The seventh-generation fighter can serve as a bridge between traditional air operations and space-based assets, creating a seamless operational environment spanning from the ground to orbit. In essence, this fighter doesn't just control the skies. It dominates the space between sky and space itself, an area no potential adversary can currently contest. The strategic implications for American power projection are profound, ensuring dominance across all domains of warfare for decades to come. While the seventh-generation fighter itself represents a technological marvel, its true force-multiplying power comes from its ability to coordinate and control an entire ecosystem of unmanned combat vehicles. Beyond the loyal wingman concept being developed for sixth-generation fighters, the seventh generation implements what military planners call distributed combat swarm intelligence. the ability to simultaneously control dozens of specialized unmanned vehicles, each with distinct capabilities. These aren't simple drones, but highly sophisticated combat platforms that extend the fighter's capabilities. Penetrator drones designed to suppress enemy air defenses, sensor platforms that expand the battlespace awareness bubble, electronic warfare units that create corridors of electromagnetic superiority, long-range strike vehicles that can prosecute multiple targets simultaneously. Through its advanced AI and secure quantum communication networks, the pilot can direct this entire combat ecosystem as naturally as moving their own limbs, transforming a single aircraft into a comprehensive strike package with capabilities previously requiring an entire air wing. This distributed approach also provides unprecedented resilience. Even if some components are lost, the overall system maintains effectiveness. It's no longer about the survivability of a single platform, but the collective capability of an integrated system. The cost implications are equally significant. Rather than building numerous expensive manned fighters, this approach allows for a smaller number of 7th-generation command platforms, controlling larger numbers of less expensive unmanned systems, delivering more combat power at potentially lower overall cost. For America's adversaries, this creates an insurmountable problem: how to counter not just a revolutionary aircraft, but an entire integrated combat system that can adapt and reconfigure itself in real time based on battlefield conditions. What does all this mean for American security and global stability? The operational impact of the 7th-generation fighter cannot be overstated. First, it ensures American air superiority for decades to come. In any potential conflict, control of the air is the essential first step that enables all other military operations. With this technology, that control is virtually guaranteed. Second, it serves as a powerful deterrent. Potential adversaries must now consider that their most valuable assets and advanced defense systems can be neutralized at any time, from anywhere, with little to no warning. This changes strategic calculations and makes aggressive actions far less attractive. Third, it dramatically reduces risk to American personnel. The combination of unmatched survivability and the ability to project power through unmanned systems means fewer pilots in harm's way while maintaining or increasing overall combat effectiveness. Perhaps most importantly, the 7th-generation fighter restores America's technological edge at a time when many had begun to question it. While countries like China and Russia have made significant investments in their own advanced fighter programs, this technology leap puts America firmly back in the lead. Former Secretary of Defense Robert Gates once observed that the enemies of the United States will never again allow us to fight the kind of war we would prefer. The 7th-generation fighter changes that equation, allowing America to dictate the terms of engagement in any future conflict. For our allies, this technology represents a reaffirmation of America's commitment to their security. For potential adversaries, it's a clear message that military parity with the United States remains out of reach. In a world of increasing geopolitical competition, the 7th-generation fighter may well be the decisive technology that maintains the peace through unquestioned strength. The story of how this revolutionary aircraft came to be is as impressive as the technology itself. It represents everything that makes America exceptional in terms of innovation and determination. Unlike traditional defense procurement programs that often stretch for decades, the 7th-generation fighter emerged from a different approach, one that leveraged America's unique innovation ecosystem to produce results with unprecedented speed. Rather than a traditional top-down development program, this initiative brought together elements that showcase American strengths: collaboration between established defense contractors and cutting-edge tech startups, partnerships between national laboratories and private industry, integration of civilian AI research with military applications, rapid prototyping methodologies borrowed from Silicon Valley, a willingness to take calculated risks on revolutionary approaches. This approach allowed developers to bypass traditional bureaucratic obstacles while maintaining the strictest security around the program. By bringing together the best minds from across the American technological landscape, not just traditional defense contractors, the program achieved breakthroughs that would have been impossible in a conventional development cycle. It's a testament to what America can achieve when it mobilizes its full innovative capacity toward a common goal. The result is not just a new fighter jet, but a new model for how critical defense technologies can be developed in the 21st century. As one program participant noted, this wasn't just about building a better aircraft. It was about reimagining what's possible when you combine American ingenuity with a clear national purpose. As we've seen throughout this exploration of America's seventh-generation fighter technology, we stand at the threshold of a new era in military aviation. The convergence of artificial intelligence, hypersonic propulsion, multispectrum stealth, and atmospheric exit capability creates something greater than the sum of its parts, a revolution in aerial warfare. For America, this represents not just a military advantage, but a reaffirmation of our technological leadership in a century that will be defined by competition between great powers. It ensures that our men and women in uniform will never enter a fair fight. They will always have the decisive edge. For our adversaries, it presents a clear message. America's technological superiority remains unchallenged. Any aggressive action will be met with capabilities they cannot match or counter. And for the American people, it stands as proof of what we can achieve when our innovative spirit is focused on a clear national purpose. The same ingenuity that gave the world flight itself has now redefined its future. As we look ahead, the seventh-generation fighter program points toward even more revolutionary developments in aerospace and defense technology. It isn't an endpoint, but rather the beginning of a new chapter in America's ongoing commitment to peace through strength. The skies have always represented freedom to Americans. Now, they also represent unquestioned security for generations to come. If you found this deep dive into America's most advanced military technology informative, please take a moment to like this video and subscribe to our channel for more exclusive coverage of defense innovations that are shaping our future. Your support allows us to continue bringing you these insights into the technologies that keep America secure. Thank you for watching, and God bless America.